Hello guys, and welcome back to this another Arduino tutorial. And in this tutorial we're going to be using ultrasonic sensor, and we'll be seeing that how we can use this ultrasonic sensor to get some distance and to measure distance of the objects. Okay, so before we do anything else, I just wanted to clarify that what an ultrasonic sensor does and how does it work. Alright, so this is a very basic image of an ultrasonic sensor. This is HCSR04 ultrasonic sensor, which we are also using in our Arduino kit, and it's really simple and really easy to use module. And how does it work? Basically, it has a transmitter and a receiver. Alright, these two things look like eyes, and you can identify them very quickly. And what does the transmitter do is it sends an ultrasonic signal or an ultrasonic sound wave. Now, what are ultrasonic sound waves? Ultrasonic sound waves are, really large, really small frequency. Ultrasonic sound waves are really large frequency sound waves, and they are inaudible to human ears, but they are fairly effective, and these sensors use those ultrasonic sound waves. All right, so transmitter sends a sound signal as sound wave, and whatever that object it is looking at will reflect that wave, and the receiver will receive that wave. So how it will calculate that distance from sending and receiving a wave? So how does it work is that when a wave is sent, the ultrasonic sensor starts counting the time, all right, until the wave is received. Now you have a time when you send a signal and you receive a signal. You have a time of how long it took for the signal to go out and come back, all right. Now you know the speed of the signal, and now you know the time it took for the signal to go out, hit the object, and come back. So you can derive the distance very easily using simple physics. And speed is equals to distance over time, so you can find distance by multiplying speed and time. But in order to do when you do that, you will get the whole distance from the transmitter to the object and back. So you divide it by 2 because you only need the distance from the transmitter to the object, or from the sensor to the object. So that's how you get a distance, right? It's fairly easy and it's fairly simple to use. Now coming back to the code, and as you can see that there are some new things in this code, and we're gonna figure out what these things are. Alright, so first of all, in the first line we have hashtag include newping.h. Now what is this? Now newping.h is a library which is created by some people, and you can find this library very easily on Google, and you can find it on the Arduino official website. And this library makes it really easy for you to use the ultrasonic sensor because it has all the code that is required to you to access and use the ultrasonic sensor very effectively. So it has some methods, and we're going to use those methods for our advantage. As it is being said, when something is already done, you don't do it again, you make use of that thing, and that's exactly we are doing what we are doing here. All right, so first thing is include newping.h. Now second is define. Now we are defining the variables such as trigger, echo, because trigger and echo are used by this new ping library. Okay, so we need to define the variables and the pins that trigger and echo are connected to. All right, so what are trigger and echo? Trigger and echo are basically the pins, that the 4 pins. These are two of those 4 pins, and if I can just zoom in and show you, right, as you can see that we have VCC, trigger, echo, and ground. Okay, so trigger and echo are the two data pins that this ultrasonic sensor uses. So we have to tell the ultrasonic sensor on which pins are these two data pins are connected. Now the third thing is max distance, which again this library uses, and we have set it to 200. That means that this library will only show us distance till 200. After that it won't show us anything. All right, so why are we using 200? We can also use 400, 600, 800, and mind you, these are in centimeters. Okay, so if you use 200, uh, because why are we using 200? That's a very good question, and let me just give you some light on that. That 200, because we are only using it to measure 200 centimeters, right? Because this sensor works in sound, and sound propagates in all directions equally, there is a high chance that after some distance the sensor will start to give you random values, because the sound is propagating in all direction and it's making basically a cone in front of the sensor. It's making like a cone. If I can explain, if I can show you, it's making a cone like this in all direction. So there is a high chance that after some distance the the precision of the sensor or the distance that we are actually getting might not be correct. So we try to use as lower distance as close to the sensor as possible, so our our distance measuring capabilities are not affected by that sound propagation all the way. Right now in the next line we are creating an object. Object is basically, you need to create an object to access any of the methods of the library. Okay, so we are creating an object, new ping sonar, and we are telling it that, hey look, I will call the object sonar, and all the arguments of the object are trigger, echo, and max distance, because that's what the library needs, right? In setup we are using serial.begin so that we can see how much distance we are away from that particular object, so it can print on the serial monitor. In loop we are using a delay of 50 milliseconds, so that the value, we don't get bombarded by the values, we can actually see them printing. And we are using serial.print ping, and this line is very important: serial.print sonar.ping underscore centimeter. All right, so we are using sonar object dot ping underscore centimeter is in method of this new ping library. Okay, so we are using that object to tell the library, hey look, I want this method to be executed, and it will do that. So it clearly shows that we are getting distance in centimeters, and this library is very capable to give you distance in millimeters as well as in inches. So whatever floats your boat, you can use that, right? And then we are printing centimeters, just so for some confirmation, and we are going to the next line and doing it all over again. All right, so let's see how this code works. I have already uploaded it, so let me just upload it again. Upload. Once it's done uploading, we can go to the serial monitor, and we can see that see, it's starting printing. Okay, so right now I have placed my hand 10 centimeters from the sensor, and if I move my hand away from that, you can see that it starts increasing till 16, 17, 18, 20, and if I move my hand closer, it will go down. All right, so this is a very easy method to and if I touch my hand on the sensor, it's gonna read 0. All right, so this is very easy method to get centimeters or get distance from an ultrasonic sensor. I'm sure there are hundreds of the ways to do that, but this is what I prefer, and this is very simple and very easy to explain and to understand by yourself. All right, if you need any more documentation on the newping.h library, you can just search on the Google and search on Android Arduino forms. I'm sorry, I said Android. So you can search on Arduino forms about that, and you will find plenty of help around there. There are many people like me who are trying to explain it to people who are just starting. All right. So this is it for the ultrasonic sensor, and I hope you learned something. Best of luck. See you in the next one.